when you are. Alright, you guys. Today I'm going to drop some knowledge on you about autosomal recessive polycystic kidney disease. That's a mouthful. Alright, I'm going to start with a quick intro into cell communication. So, why is cell communication so important? I want everyone to raise your hand up. Everyone. Alright. Pretty simple, right? You can put them down. Simple, correct? Actually, it's not. It's like, all that is like thousands and thousands and thousands of cells being triggered by your brain, by your nerve, your nervous system, to move. It's crazy, right? Well, what does that have to do with your kidneys? I'm about to get there. Alright. There are two basic forms of cell communication: is local and long-distance signaling. In local signaling, cells will make direct contact to transmit messages through synaptic signaling and growth factor and paracrine signaling. However, in long-distance signaling, hormone cells are released from one part of the body and go through the bloodstream to reach another part. Alrighty. And, there's 3 steps to this pathway, the whole, cell thing. I'm going to draw it on the board because it's going to be important to use later. Alright, we're going to start with reception, in which there is a receptor protein, and there is a ligand, which is a signaling molecule. Sorry, my hands are real shaky. And it binds and it triggers a response within the cell. Alright, and then we get to transduction. Transduction is when this response goes throughout the cell, kind of, and this is really important, okay? You got things like, there's 2 secondary messengers. There's calcium and there's cyclic AMP. And these transmit messages throughout the cell for all these different things. So this is cyclic AMP, and this is calcium. Alright, and this triggers out things with, especially proteins with calcium. It triggers the proteins to do a certain thing. And then we have the overall response, which it all leads to a certain big thing. Alright, so now we get to the kidney disease part. Alright, autosomal recessive polycystic kidney disease is an autosomal recessive trait. It's on the chromosome 6, and it is located on the 21st gene. So gene 6p21. Alright, and see, the mutations appear to be scattered randomly throughout the gene. It doesn't really cluster on any specific part, so there's no specific part of the gene necessarily that it affects. Alrighty, it's characterized by cysts on your kidney. So it's like big old bubbly things on your kidneys. And most of them will actually die before they're born. There's only 1 in 20,000 live births with autosomal recessive polycystic kidney disease. And the few that do live, most of them die in the infant period, but there have been a few special cases where they will live into adulthood, but they won't live very long, fulfilling lives. It's kind of sad. But symptoms will include undeveloped lungs, high blood pressure, problems with blood flow to the liver, and excessive peeing and thirst. Now, the big thing with your cell signaling with the kidney disease, there are actually a lot of things that contribute with the cell signaling, but the main issue is your calcium. Alright, your gene, the PKD, which is the polycystic kidney disease gene, it encodes a protein called polycystine. So basically, it's this little protein, and it's involved in a lot of signal transduction pathways. So basically, in polycystine, there's a big imbalance in the kidney disease. There is a big imbalance in the polycystine. So there's a whole bunch of these modes. And basically, what they do is they stop the calcium from being able to do its job. The calcium can't do its thing. So then the cyclic AMP freaks out, and it's like, oh God, I have to really, 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 really do a whole lot of stuff. And that leads to a bunch of abnormal growth, like the big old cysts. So, sorry. And basically, it's overdoing itself because the calcium can't do anything. The calcium can't contribute necessarily. Whew. And then a few other things that I really want to cover real quick with the kidney disease and the cell signaling is there's also an issue that it can be caused with your ligand, your growth factor, right? There's a certain one that is like the little certain shape, and it's supposed to be a certain type of signaling. Well, the thing that it does whenever it does this is this one connects to it, right? This is called TGF beta. That's what it's transforming growth factor beta. So basically this connects here, and it's like, oh, this is the one that's supposed to connect here, right? And it's like, oh, psych, not really. And it like transforms into something completely different, which goes all crazy, and it causes like a crazy different cell response that isn't what was supposed to happen. And it can just messes up a whole lot of stuff, like the whole like excessive peeing and thirst and the high blood pressure and stuff. That's the part that causes all those external symptoms aside from the kidneys. Correct. And then alrighty, and also in addition, with some of these other symptoms, the whole calcium activated thing, calcium also plays a big, huge part in cell death. So whenever your calcium is affected, your cell death can't quite do what it's supposed to. And basically, like with the apoptosis, whenever like it doesn't perform correctly, and instead of actually like dying and going away, the cell actually swells and becomes larger and larger and larger. And all right. So basically, whenever we get to the whole treatment part here, the thing with the cystic cells is they can be sort of treated to make the cysts decrease, but there's nothing that's going to stop this from happening because it is a gene disorder. So there's no real correct treatment for it. Your cysts, and you can be comfortable, but you're always going to like have these big problems with your cells, and it's just really, you don't have a good life expectancy. It's not a good prognosis in general. And anyways, that's all I've got.
Okay. All right. Very good.
I tripped over my words.
I mean, what you were saying.
All those
Yeah,
mugs.
the zone.
All the mug, like I got it. I say the mug.
I kept on saying
It's all right. I really did. I understood it.
You're getting a different person.
Let me ask you a couple questions. The reason why a person has a bad prognosis is because of the cysts.
For the most part, yes.
So what
because
is
you
the
have to have-
cysts gonna do to the kidneys?
your kidneys just can't function properly.
And so they can't just go on like dialysis in replacement of that?
It doesn't work as so it's supposed to, like the whole dialysis with the kidney fluid. Well, your kidney fluid doesn't even form as it's supposed to in the first place, so putting in anything, it's not going to fix it.
Okay, so from the beginning, your kidneys are messed up, so even like,
Yeah,
you can't even go in and have treatments through dialysis. Alright, that makes a lot more sense. Okay, and then you said that most people aren't even born who have this.
Yes.
Or they die before they're ever born.
they die in the
In utero.
in utero, the prenatal period.
Okay, so the cell signaling on this, are there several besides just these
There's
two?
actually several besides these two, but I couldn't get necessarily as in depth in all of those because calcium was really the big part. But there's also some other things such as like the cilia that makes cells move around.
Mhm.
Those are affected. I couldn't really get a for sure thing on that. But then like it was that, and then the TGF beta, I found a whole lot on that.
So the calcium in that case, the ligand bonds and it goes through its normal transduction, but you have too much of the, what is it that's around the calcium? You make too many of those?
The polycysteines.
Okay, the polycystin, that's a protein, correct?
Yes, it's a protein encoded by the polycystic kidney disease gene.
Okay, so that's the gene that protein's faulty because of that gene.
Because of
And that causes the cyclic AMP to go crazy.
Yes, and it goes crazy, and it goes with abnormal growth.
And that makes the whole cell grow, which forms the cyst.
Yes.
And then the other one was it's like a imposter, and it bonds with the receptor, and then that causes it to swell.
Yes.
Okay, so what's the average life expectancy of someone with this?
Well, 30 to 50% die in infancy period if they are born. The rest of them mostly die in endosselints, but I actually know somebody that had polycystic kidney disease, and he only had it on one kidney, and he actually lived to be 32.
And it was because the other kidney was
Because
perfect.
the other kidney was unaffected, but then again, it still eventually threw off everything.
So you can have it on one kidney.
You can have it on one kidney, but typically with the autosomal recessive, you won't end up having it on one kidney. There's also an autosomal dominant, in which there's a whole lot more live births there, and there's a whole lot more possibility of it happening on one kidney.
Really? Well, that's quite interesting. All right, does anyone have any questions?
All right, bring it in.
Okay, so you might have mentioned this, I might have missed it, but can you have just, I just lost the word, a transplant, a kidney transplant?
It wouldn't work because your cells would still be doing all of the
It would still be making all those extras.
yes, all those extras, so it would still be.
You have to change the gene in order to.
I didn't think about that, my bad.
Okay.
Okay. So, the person you knew who only had it on one kidney, could they just take that kidney out? Cause you can function with only one. So could they just take it out and he'll be alright?
Well, then again, there are also the other symptoms such as the underdeveloped lungs and the high blood pressure. Those are also important things because the polycystine also affects many other signal transduction pathways. It's just the polycystic kidney disease is characterized by the cysts on your kidney. That's not all
So
it affects.
polycystine's not just in your kidneys, that's.
No, it affects dozens and dozens and, well,
Okay.
actually trillions of different transduction pathways in your body.
Good deal.
Can scientists know whenever you get pregnant, can they tell that the child has it or?
It's a little bit later, more into your second trimester that they can tell, but they can eventually tell.
Is it painful or anything? Can you feel this? I know some of them, you lose hair, there's features that show on the outside.
You can't see it from the outside, and you can't necessarily feel the cyst, but you feel all of the pain. Whenever you pee, you're gonna feel a lot of pain. You're gonna be constantly peeing too, so you're gonna be constantly just painfully peeing, and you're gonna be drinking all the time, and you're gonna have problems breathing because of your lungs being underdeveloped, and you're gonna have high blood pressure, and it's gonna,
So you'll always be dehydrated pretty much.
you're not always gonna be dehydrated necessarily. It's just all of your everything that all of your peeing stuff and all that, it's all gonna be overactive, so you're gonna be just constantly doing stuff even though it's not necessary. Not necessarily that you're dehydrated.
You don't realize how much your kidneys affect. When your kidneys start acting up, that leads problems to your bladder. When your bladder starts acting up, that starts leading problems with your blood pressure. When your blood pressure starts acting up, that starts causing nervous system disorders. That's what we've been going through with my dad, and it's taken us 4 weeks to get him back normal, because his kidneys started acting
Is
screwy.
that why after a lot of surgeries, they're gonna watch your kidney function?
Yeah, because if it starts slowing down, that leads to all kinds of problems. It was very interesting. I really
After heart
enjoyed it.
surgery, they had Papa on the time schedule to go to
See,
the bathroom.
that's the way my dad is right now. He's supposed to get up every 3 hours and go to the